How is it that saying we're done becomes an understatement? Because I overlook things. And one of the things I wanted to make certain that we talked about was how to use an offset list in context of named mode operations. And the easiest and best way to do that is to return to our topology. And what we're going to do is we're going to use R1 in order to be able to do some manipulations. Let's take a look at what goes into this. Now, the main objective is going to be to recognize the fact that we have prefixes being advertised on R1. Show IP EIGRP interfaces, and we'll see that we're advertising these 8 interfaces here that we usually use to play around with our summarizations. Now, these 8 are participating in EIGRP and they're going to be learned, but what I want to do is I want to come up with a learning scenario. Here's the scenario. I want to make certain that if I advertise prefixes to R22, I want to make certain that R22, let's see, I'll pick another color here, that R22 is going to use R2 to reach these prefixes. Now, the way that I'm going to do this is I'm going to go in and I'm going to advertise, use the offset list, again, in an outbound direction on R1 on the interface that's connected to SW1. Now, let's look at this. All right, so on R1, we'll do a show, pardon with me, we'll do a show CDP neighbors, and we'll see whether we're connected to Cat1 via this idea of 0, 0. Now, let's see, I've already forgot which path I want to take. So I want to use R2. So what I'm going to do is I'm going to advertise a higher metric out 0, 1. So that's going to be where I'm going to do my manipulation. I'm going to send out 0, 1, and I'm going to add 1,000,000 to my metric. All right? Now that means I should prefer R2 in order to be able to reach the prefixes being advertised by R1. And all I'm going to do is in this very short video is illustrate the fact that we need to go to the topology base configuration in order to be able to configure our offsets. So let's take a look at that. So on R1, what do I want to do? Well, first I want to match my prefixes. So let's see. What I'm going to do is I'm going to say do show access dash list. And let's see, do I have any access lists? And let's see. We're going to match a series of prefixes. So how best to do this? So what I am going to do is I'm going to say access dash list 1 permit. And what am I going to permit? Well, I want to permit any one of these prefixes that's even. So any one of these prefixes that's even. So 255, 252. So even in, or 254, even in the third octet, 255. Notice it took the command. So now what I'm going to do is I'm going to go to router, EIGRP, named, and I'm going to go to the address family, IPv4, unicast, autonomous system, 10. And what I'm going to do is I'm going to see, can I type offset list here? No, I can't. Can I go to the interface? AF interface default. Can I type offset list here? No, I can't. Where do I need to be? I need to be in the topology base config. And once I'm inside the topology base config, I can now enter the access list. Now what I'm going to do here is I'm going to say I'm going to use offset list 1, and I'm going to do it out, and I want to do the 1,000,000, and I'm going to specify interface E01. So let's see, did I get the 1,000,000 right? Yes, I did. So let's see what's happening now. So what I did is I just made it a little more complicated since we've already done this before. So what I did is I said any even prefix is going to get advertised out this with a higher metric because I'm offsetting them. So what should happen is that I should use R2 to get to my even, and I should use R3 to get to my odd prefixes. Let's take a look and see exactly what happened. Again, I probably should have labbed this up before I decided to use this as an example. But where's the fun in that, right? Show IP route, EIGRP, and we're looking at our 11s. And what we're going to see here is our 11s are all being learned through serial 2.0. Now, why is that? Let's take a look at this. Show IP interface brief, E assigned, And that's because serial 2.1 is shut down. No shut. So let's wait for it to come up. We should get our peering. So show IP EIGRP neighbors. We'll wait for the interface to come up. There we go. The neighbor should be up. Notice we're good to go. We are using a 0 for our queue count, so everything should be good to go. So now let's look at what's going on with our interface or our routing table. Let's go down to 11. And what are we seeing here? Well, we're seeing the fact that our evens are indeed going to use R2. So 0 is going to use R3, 2 is going to use R2. These are our evens. Evens are going to use R2. But our 5s, our odds, notice our odds are going to be load balanced. Let's look at this. So trace route to 11, 11, 0, 11 is going to go through R2. We know that because of the 2 here. Now what's happening with my odds? Well, if we notice, my odds are being load balanced. Well, that's not what we wanted to do. I said we were going to change it up. At first I was just going to change everything, but we'll do that when we can do something fun, right? So what I want to do right now is I want to do the manipulation such that the other prefixes are not going to be load balanced. So I want to make certain that my evens are going to go through R2 and my odds are going to go through R3. Let's look at that. So we need to again return to R1. And what are we going to do? Do show run section router EIGRP. And when we look at this, we see we have this offset list using 1. So let's take a look at access list 1. Do show access list 1. Well, here we go. Well, notice this is only matching on evens. So let's modify that. Let's create a new access list. Let's say access list 2 permit 0010 255 255 254 255. And what are we going to do? We're going to go back under the base topology and we're going to do our configuration there. So I'm just going to grab EIGRP named and plug it in. Offset list, calling access list 2 out. I'm going to say I'm going to add 1,000,000 to it, and it's going to be out of do show CDP neighbors. We want it to go out 0, 0. So just up arrow E 0, 0. Let's go ahead and take that remark out. That should clear my connection. And if I got all of my sums right, do show access dash list. Should force resync, which it did. So let's take a look at it now. Now we're matching on both access list 1 and access list 2. Let's return to R22, show IP route. Let's just button down to our 11s. And now what we should see here is the evens are going to go through R2, the odds are going to go through R3. Let's do a trace route just to verify it, and then we'll wrap up this part of our presentation. So trace route to 11, 11, 0, 11 should go through R2, which it does. And let's go ahead and pick 7, 11 should go through R3. Now if we took the time to test each and every one of these, we would find very quickly that all of them are going to be in, because we can see it in the show IP route that they're picking alternate interfaces to go through. The main point here again is that if I go to an interface, config T, interface, serial 2.1, and I shut that interface down, what's going to happen is all of my feasible distances, all my feasible successors, excuse me, are going to be installed into the routing table immediately without doing any type of queries. Do show IP EIGRP topology table. And what are we going to see for these 11s? We're going to see that we have multiple entries. We have a single feasible distance, but keep in mind this value right here is not going to be the one that gets picked, but since the advertised distance is less than the feasible successor, or the feasible distance of the successor, we match the feasibility condition, so those prefixes are going to become available to us immediately once we bring the interface down. So I'm going to come in here, I'm going to say shut, and what we'll find is the moment that it goes down, show IP, EIGRP, show IP route, EIGRP, we're going to use nothing but serial 20 to reach our destinations. So everything's going to go through R2, excuse me, trace route to 11, 11, 0, 11. It's going to go through R2, but so are our odd configurations. So we'll just say 1, 11, 11. It's going to go through R2 also. Now the point here is that we also need to recognize here that we have an issue in our topology. Notice that they're not taking the same route. We're using that link 2, 3 between R2 and R3 to get information down to R1. And that's going to be by virtue of the fact of where we did our manipulation. So keep in mind, it's going to be really important for us to understand that as we make these changes in our infrastructure, it's going to impact how traffic is going to go. And we need to be mindful of the fact that not all traffic is going to be using synchronous routing, which means it's going to return traffic is going to return via the same path that it went to get to its destination. We can have asymmetrical pathing in our infrastructure, and it's only an issue if Cisco says it's an issue. So again, understanding how we're going to be doing these manipulations and how we can use this idea of offset either in named or classic mode is extremely important. And with that said, now let's start taking a look at how we can manipulate things based on administrative distance. I'll see you guys in that presentation. Bye-bye.